Hello, today's video we're going to be discussing significant figures. By definition, significant figures are the numbers in a measurement that are considered true plus one which is somewhat doubtful. Okay, so here in the illustration I have a ruler, and if I were measuring this yellow object, I could see that it falls somewhere between 4 and 5 centimeters. So if I let each one of these be 0.1, 0.2, 0.3, 0.4, etc., I can see that the object, I'm sure that it's 4, I'm sure that it's 0.3, and I can see that it falls somewhat to the left of the center, so I'm going to say, oh, it's about a third. I'll say 4.33 centimeters. So that will be a measurement to a proper number of sig figs, or significant figures. Now, remember now that exact numbers do not have significant digits. So if I were to say that 1 minute equals 60 seconds, okay, this 60 seconds, I don't use that number to determine significant figures because it's infinitely large. All non-zero digits in a measurement are considered significant. So like 152 millimeters, that has 3 sig figs, okay? Or let's say 11532 all those numbers, if they were in a measurement, would be considered significant. So 1, 2, 3, 4, 5, 6 significant figures. Zeros, which fall between two non-zero digits, are always significant, such as 105 centimeters. It has 3 sig figs because 0 falls between two significant figures, or two non-zero digits. Okay, we can do one more. 0.01503. Okay, so there's 4 sig figs there. Okay, because that 0 falls between non-zero digits. Zeros which act as placeholders are not significant. So if I were to say 1,000 centimeters, it only has 1 sig fig because these zeros are placeholders. Okay, like for example, this has 2 sig figs because all these zeros are placeholders as well. All right, the last one is a little bit more confusing. Zeros at the end of a number are significant if the number contains a decimal. So if I were to write 10.00, that has 4 significant digits, okay? Because that 0 here at the end is significant, and therefore those zeros fall between two significant digits. If I were to write 100 dot, okay, this 0 automatically becomes significant because of that decimal point. So therefore this would have 3 sig figs. Okay, see if you can identify the number of significant figures in each of the following examples. I'll give you a moment if you want to try this on your own. Okay, the first one has 3 sig figs because all of them are non-zero digits. The next one has 3 because the 0 falls between two significant digits. This one has 2 because this 0 is a placeholder. 3. All these are placeholders. It will have 1. And these zeros are placeholders, so this one will have 2. Here, everything is significant because I have a decimal, so the last 0 is significant automatically. Here, everything is significant. Same thing on this one. These zeros are placeholders, so therefore you have 2 sig figs. So I hope you got all those correct. All right, I think most people understand the concept of rounding. So if I had a number, let's say the number is 145.27, and suppose I need to round it off here. Okay, so I look at this number here. If this number is less than 5, I simply drop the number. If it's greater than 5, I round the preceding number up 1. Okay, so in this case, it will be 145.3. So I think most people understand these two concepts. The last one of those is a little bit more tedious. A lot of professors or instructors will require that you know the even-odd rule, while others will not teach it. Okay, let me go ahead and show you the even-odd rule. If the number in question is exactly equal to 5, you look at the preceding number. So suppose I'm rounding here. If the preceding number is even, then I drop the 5. Okay? Same scenario. Exactly equal to 5. This time the preceding number is odd. So if it's odd, then I'm going to round up. So my answer is going to be 145.8. So that's all the even-odd rule is. So if the number is 5, it has to be exactly 5. So I put zeros and it's still exactly 5. But if I put a 1 out here somewhere or some other number, it's no longer exactly equal to 5, but it's greater than 5, so I would just round up automatically. The rule for adding and subtracting significant figures is that the result will have the same number of decimal places as the measurement with the fewest decimal places. So on this first one here, if I were to add, I would get 15.363. Okay, so what I need to do is, if I were to line up my decimals really carefully, I have one decimal place here. So therefore, my answer can only have one decimal place. So if I round this off to one decimal place, I look at this. This is greater than 5. So I get 15.4 meters. On the next one, if I were to add these numbers, I would get 0.0273. Okay. This one has 3 decimal places, so 1, 2, 3. I need to round it off here. All right. So since this is less than 5, it'll be 0.027 centimeters will be the answer. And the last one over here, if I were to add these, I would get 265.45 centimeters. All right. This has 2 decimal places. This has 0 decimal places, and it doesn't have a units place either. So I'm going to have to round off to here. Let's see. Yes, here. Okay, so when I round this off, it will be 270 centimeters. Okay, I hope that wasn't too confusing. The rule for multiplication and division is I'll round the answer off to the same number of significant figures as the measurement with the fewest significant figures. So here I have 3 sig figs and 3 sig figs, so I know my answer is going to have 3 sig figs also. So when I multiply those numbers out, I would get something like 11.5889 centimeters squared. I'm allowed 3 sig figs, counting from the left side, so it would give me 11.6 centimeters squared for my answer. Okay, the next one. Okay, I have 3 sig figs and 2 sig figs, so I know my answer can only have 2 sig figs. So if I multiply these, I get 3.696 meters squared. And since I'm allowed only 2 sig figs, I look at this, which is greater than 5. So it's going to be 3.7 meters squared. Okay, the next one is a division problem. So if I were to divide, I would get 1.8392 and several more characters. Okay? Times 10 to the negative 2 power. All right, this one has 2 sig figs. This one has 4 sig figs. So I'm actually going to only have 2. So I evaluate here. So I get 1.8 times 10 to the negative 2 meters. And the last one here. All right, so if I were to multiply, I would get 107.26. I have 3 sig figs. 2 sig figs, so my answer can only have 2 sig figs. All right, so that 7 is greater than 5, so I need to round up. So it's going to be 1, 1. I had to put a 0 here to keep my 1 in the hundreds place, and that'll be centimeters square. If you would like, you could pause the video here, and you could work these problems and see if you get the same answers I do. All right, good luck. I'll be back in just a few seconds. Okay, so when I multiply here, I get 327.6, and that's going to round to, I need 2 places, so that's going to be 330. Okay, on the next one we're adding, so I'm allowed 1 decimal place on this one, so it's going to be 11.295. So with 1 decimal place, that would give me 11.3. Okay, I'm multiplying, so I have 3 sig figs here, 3 sig figs here, so I'm actually going to have 3 sig figs. So when I multiply, I get 138915. So 1, 2, 3, I look at this. So that's going to round off to 0.139. Okay, so here I have 4 sig figs, 2 sig figs, so my answer can only have 2 sig figs. So if I were to divide, I would get 0.2322. And since I'm allowed 2 sig figs, the answer is going to be 0.23. All right, so I have 3 sig figs, 3 sig figs, 4 sig figs. So my answer can only have 3. So when I multiply this out, I get 35.852. 352. All right, so I'm allowed 3 sig figs. So I look at this. All right, this is greater than 5. So it's going to be 35.9. Should do the one on the right next. Okay, so I'm going to do this part first. And when I do that part, I get 1.71. I'm going to divide that by 11.34. And what I do, I'm going to get 0.0151. All right, so 3 sig figs, so it's good like it is. So I'm going to multiply this then times 100.00. And the answer is going to be 15.1. Okay, again, on the next one, I'm going to do this part first. And I get 23. Because I have 2 sig figs here. So I'm going to divide that 23 by 275.15. So that's going to give me 0.08359. So on and so forth. Okay, I'm allowed 2 sig figs because of this up here. So it's going to be 0.084. Be my answer. All right, so what's the mass in grams? I have 1 gallon of water if the density is 1 gram per milliliter. Okay, so let's start with 1.00 gallons. Okay, when I multiply this, I want gallons on the bottom. I know that 1 gallon is equal to 4 quarts. Gallons cancel gallons. Okay. I know that 1 liter is equal to 1.057 quarts. The quarts on top, I need to put quarts on the bottom. 1 liter goes on top, so it's be 1.057. Quart cancels quarts. Now my liters. Okay, I know that 10 to the third milliliters equals 1 liter. Liters cancel. I have 1 gram per 1 milliliter. Milliliters cancel. All right, so after doing all the math, okay, I noticed I only have 3 sig figs. So I had to round my answer off to 3 sig figs. So my answer is going to be 3.78 times 10 to the third grams. I hope you did well. All right, thank you for watching. Please like and subscribe to my video. Okay, thank you very much. Have a good day.